This lesson is factoring by the greatest common factor, or we call it GCF. Here are some terms, definitions that you need to write down. When we're factoring by the greatest common factor, factoring polynomials can be used by the greatest common factor. And the distributive property also allows you to factor out the greatest common factor of the terms in a polynomial, and you can write a factored form of the polynomial as well. So with these two sayings here, we're going to be looking at some different examples working with factoring out the greatest common factor. Here, for example A, we have factor each polynomial. For A, we have 5b plus 9b to the third. So the first thing we want to do is factor out 5b and 9b to the third and find the greatest common factor between each of those. So when we factor out 5b, that's 5 times b. When we factor out 9b to the third, that's 3 times 3 times b times b times b. And what would be the greatest common factor of both 5b and 9b to the third? Well, it's going to be b here. It's circled in red. And then what we're going to do is we're going to write the terms as products using the greatest common factor as a factor. So what we have here is we have the greatest common factor is b, so we connect 5 times b plus, now since we took out a b, since that's the greatest common factor for 5b and 9b to the third, what we would have now is plus 9b squared times our b. So what we do is we use the distributive property to factor out the greatest common factor. So we're going to factor out this b. So we bring it outside of the parentheses. So we have b parenthesis 5 plus 9b squared. The way we check our work is we distribute back the b to each situation, and to see that you get the original answer from the beginning, which when you distribute b back in, you would get 5b plus 9b to the third. Let's look here at b. We have 9d squared minus 8 squared, so we have to factor out each of these. Factor out 9d squared, factor out 8 squared. So what we're going to do is 9d squared is 3 times 3 times d, and we have 8 squared, which is 2 times 2 times 2 times 2 times 2. And looking at this, there's nothing in common, nothing that we can factor out that goes into each of these. So in this situation, there's not going to be a common factor other than just one. And then what you could put for this is the polynomial cannot be factored any further, or cannot be factored other than 1. Here we have some other examples of factoring out the polynomials. So we have negative 18y to the third minus 7y squared. Factor out each of these by finding the greatest common factor. Before we do that though, notice how each of these has a negative in front. We can bring out that negative value. So we have negative 1 parenthesis, now this becomes positive 18y to the third plus 7y squared. It's going to be a little easier to break this apart by taking out that negative. So when we factor out 18y to the third, that's 2 times 3 times 3 times y times y times y. 7y squared is 7 times y times y. So what is the greatest common factor between each of these? Well, it's going to be y times y, which is y squared. So what we're going to do next is we are going to, since we found y squared as my greatest common factor, I'm going to pull that out and distribute it in front of my original here. So I have my negative 1 parentheses, then the y squared is my greatest common factor. Inside the inner parentheses, we then would have 18y, because 2 times 3 times 3 times y is 18y, plus my 7 left over. So my final answer here is going to be a negative y squared parenthesis 18y plus 7. Looking at the next one here, we have 8x to the fourth plus 4x to the third minus 2x squared. So we're going to factor out each of these terms. To get 8x to the fourth, that's 2 times 2 times 2 times x times x times x times x. 4x to the third breaks down, when we factor it out, it's 2 times 2 times x times x times x. 2x squared is 2 times x times x. So what is the greatest common factor here? Well, it's going to be 2 for each of these, and then each one has x squared, or x times x. So my greatest common factor is 2 times x squared, or x times x. So we pull that out of each term. So we pull that in front of the parentheses to get 2x squared, and then we rewrite whatever's left over. So we have 2 times 2 is going to be 4x squared plus 2x minus, we have nothing left here, so minus 1. So this would be my final answer after taking out my greatest common factor and rewriting it, and then we check our work by distributing that greatest common factor back into this 4x squared plus 2x minus 1. And if we get what the original answer was, then we factored out the greatest common factor correctly. Here we have a little bit different situations going on right here. And what we need to do is find a common binomial factor. So if we're looking at A right here, we have 4s parenthesis s plus 6 minus 5 parenthesis x plus 6. What is my common binomial factor? That's going to be s plus 6. Notice it's in each situation. So we're actually going to factor that out. Notice I have it in red here. So when I bring it out, I have s plus 6, and then we take this 4s minus 5 and we group that together. So what we have is 4s minus 5, s plus 6, and that would be my final answer there for example number 2. Let's look at B. We have 7x times 2x plus 3 plus 2x plus 3. We can pretend there's a 1 in front of the parenthesis right here if that's helpful to us. What is my common binomial factor? Well, what we have in common is 2x plus 3, 2x plus 3. So we're going to factor that out, but then we need to group together what's left over, which is going to be this 7x, and then we can think of a 1 right here. So the way we rewrite this is we factor out 2x plus 3, and then we group together that 7x plus 1. So my final answer is 2x plus 3, parentheses 7x plus 1. Here we have some more examples. 3x, parentheses y plus 4, minus 2y, x plus 5. Now, looking at this situation, we do not have a common binomial factor. Notice that y plus 4 is not the same as x plus 5. So there's nothing in common here we can factor out. So for this answer right here, we would just say the expression cannot be factored, and we're done. Now if this was y plus 4, y plus 4, then that would be a common binomial factor, but that's not what it's showing, so we can't factor it out, so it's not factorable. D, we have 5x, parenthesis 5x minus 2, minus 2, parenthesis 5x minus 2. Here we do have a common binomial factor, which is that 5x plus 2. So we're going to factor that out, but then we group what's left over, which is 5x and that minus 2. Notice in red, 5x minus 2. That's my common binomial factor. So to rewrite my final answer, we bring out my factor, common factor, which is 5x minus 2, and then we bring together what's left over, 5x minus 2. This will be my final answer. One thing to think about, since they're both 5x minus 2, there's two of them, you can write this as 5x minus 2 squared, just something to take it a step further. Here we are going to factor each polynomial by grouping. So here we have 6h to the 4th minus 4h to the 3rd plus 12h minus 8. Think of this being in standard form. Because the exponents are in descending order. And so what we're going to do is we are going to group terms that have common numbers or variables as a factor. And then what we'll do is we'll factor out the greatest common factor of each. So the way we're going to group this is the first set and the second set. So 6h to the 4th minus 4h to the 3rd, 12h minus 8. So we group the terms that have common numbers or variables as a factor. So we're going to factor out the greatest common factor. So looking at the first set here, it's going to be 2h to the 3rd, because 2 goes into 6, 2 goes into 4. And we have h to the 4th, h to the 3rd. Since they both are involving the variable h, we can pull out h to the 3rd. For the second part here, 12h minus 8, 4 goes into 12, 4 goes into 8, so we can pull out a 4. So we factor out greatest common factor of 2h to the 3rd and 4. And notice, once we factor that out, we have a common binomial factor, which is this 3h minus 2. So now we can factor that out and rewrite my final answer similar to previous examples. So 3h minus 2, we factor that out, and we bring together the remaining values. So my final answer here is 3h minus 2 and 2h to the 3rd plus 4. And that would be my final answer right there. Looking at B, we have 4r to the 3rd plus 24r plus r squared plus 6. We're going to group our terms. So to group them, we'll group the first set and we'll group the second set. So 4r to the 3rd plus 24r plus r squared plus 6. We're going to factor out a greatest common factor. So think which value and variable we could factor out with this first set. That's going to be 4r. What value or variable can we factor out with the second set? There's nothing in common we can factor out, so we would just factor out a 1. So what do we have in common with our binomial factors? That's going to be r squared plus 6. So the way I'm going to write this is going to be r squared plus 6, and then I bring together this 4r plus 1. So final answer is r squared plus 6, 4r plus 1. That is it for this lesson, and we will go over any questions you have in class tomorrow.